Good morning. Today we are about to learn how to represent real-life situation using rational functions. First, let's have a short review about polynomial function. So polynomial function is a function which involves only non-negative integer powers. Let's see some examples. F of x is equal to 3 having the degree of 0, which is called constant function. It is a polynomial function since 0 is neither positive nor negative. Second, we have f of x is equal to negative 2x plus 1, having the degree of 1. Also called linear function. Next is f of x is equal to 3x squared plus 2x minus 7, having the degree of 2 since the highest exponent is 2, which is also called quadratic function. Lastly is f of x is equal to 4x cubed plus 2x minus 7, having the degree of 3. Again, since the highest exponent is 3, with a special name of cubic function. So let's define rational functions. A rational function, r of x, is a function of the form r of x is equal to p of x over q of x, where p of x and q of x are polynomial functions, and q of x is not equal to 0. The domain of r of x is a set of real numbers such that q of x is not 0. So the very important part in here is that the denominator should not be equal to 0. Let's have an example. So first, we have r of x is equal to x cubed minus 1 over x plus 1, where x is not equal to negative 1. Since if we let x equal to negative 1, we will have negative 1 plus 1, which is equal to 0. And from our definition, q of x, our q of x should not be equal to 0. Since if we let this to happen, the whole function will be undefined, does not exist, or undetermined. Let's have another example. F of x is equal to 1 over x, where x is not equal to 0. Again, we cannot let the denominator be equal to 0. Last example, we have y is equal to 1 over x squared minus 4, where x is not equal to positive or negative 2. Since if we square positive 2, the answer will be 4. Same if we substitute the value of negative 2 and square it, the answer will also be equal to 4 minus 4, which will give us 0. So let's have our first problem. The local government unit allotted a budget of 100,000 pesos for the feeding program in the daycare center. The amount will be equally divided to all the pupils in the daycare center. Write an equation showing the relationship of the allotted amount per pupil represented by f of x versus the total number of children represented by x. So we should take note of the important details, which are the 100 pesos, which is the allotted budget that will be represented by f of x, and the total number of children that will be represented by x. So let's have a table and examples. If we have 10 children, the allocated amount per child will be 10,000 pesos. If we have 20 children, the amount will be 5,000 pesos each. For 50 children, we will have 2,000 pesos per child. If we have 100 children, they are going to have 1,000 pesos. And if there are 200 children, each child will have 500 pesos. Notice that as the number of children increases, the amount allocated per child decreases. So for this one, we can have f of x, or the allocated amount per child, to be the total allotment, the total budget allotted, divided by the number of children. Let's have problem number 2, which is in connection with problem number 1. Suppose a benefactor wants to supplement the budget allotted for each child by donating additional 650 pesos per child. If h of x represents the new amount allotted per child, construct a function representing the relationship. Again, we take note of the important details, which is the additional 650 pesos per child, and h of x as the new amount. So using the same table, but since every child will have additional 650 pesos, the allocated amount per child will have additional 650 pesos. So for this one, there should be h of x, since in our problem, h of x will represent the new amount. So the representation of the rational function is h of x is equal to 100,000 over x plus 650 pesos. Let's have problem number 3. A car is to travel a distance of 70 kilometers. Express the velocity v as a function of travel time t in hours. So let's take note of the important details, which are the 70 kilometers, the velocity v as a function in time t hours. So let's use again a table. If we have 1 hour to travel the distance of 70 kilometers, the velocity will be 70 kilometers per hour. If we travel 2 hours, the velocity will be 35 kilometers per hour. For 3 hours, we have 23.33 kilometers per hour as the velocity. For 5, we have 14 kilometers per hour. And for 10 hours, the velocity will only be 7 kilometers per hour. So again, notice that as the time increases, the velocity decreases. Since we have shown the relationship between the two, thus the function of velocity v in time t is equal to 70 over t. Problem number 4. Manuel has 10 cups of flour to be used in baking cakes. He wanted to split it evenly among the containers that he will use so that he can adjust the measurements of other ingredients. Construct a function c which would give the number of cups of flour each of the number of containers n will have. So the important parts are 10 cups of flour, the function c, and the containers n, or the number of containers. So for this one, we can have the function c of n is equal to 10 over n, since we're going to divide the 10 cups depending on the number of containers, which is represented by n. Problem number 5. The distance between the school and your home is 5 kilometers. Express velocity v as a function of travel time t in hours. Let's take note again of the important details, which are the 5 kilometers, the velocity v as a function, and the time t in hours. So for this one, let's have this triangle regarding the formula in solving velocity, distance, and time. If we are going to find velocity, we will have distance over time. If we are looking for the distance, we can have velocity, or the speed, times the time. And if we are looking for the time, then that will be distance over velocity. So for this one, since we are looking for the velocity, we will have the distance over time, which is 5 kilometers over time t. So the function velocity in terms of time is equal to 5 over t.